In this video tutorial for GrandPrix Race Manager, we will cover step 4, which is going through the hardware settings to configure and test your hardware devices. This tutorial is using version 22 of the software. However, much of what we will cover applies to other versions of GrandPrix Race Manager. On the Overview tab of the main screen, click on the shortcut button for step 4. That will open up the Hardware Settings screen. This screen has one tab for each type of device that can interface directly with the software. We will start off with the Timer tab. On the Timer tab, you can configure the software to use your timing system and to test out the interface. In the Timing System section, if you have one of the supported timers, select it from the list. If you are using some other timer, select the Other Serial Timer option. Then click on the Custom Settings button. This opens up the Custom Timer Settings screen. You will need to know the COM port settings that the timer uses, any commands that the timer can accept, as well as any responses that the timer sends. Each of these is explained in the software's help file. You can click on the Help button to access that help section. Save the settings once you are done. For this demonstration, I will use one of the supported timers, so I will cancel out of this screen. The next thing that you need to do is select a serial port. Any serial port currently installed on your computer will be listed on this drop-down list. If you are using a USB to serial adapter, you will need to make sure that it is plugged into the computer before you open up this screen. Also, you will need to make sure that you installed the drivers for that adapter. The USB drivers, when properly installed, will create a virtual serial port that the software can use. Note, with most USB to serial adapters, the serial port number will change when it is plugged into a different USB port on your computer. So, we recommend using the same USB port for your testing and when running your race. In the Time Options section, you can set the DNF time. DNF means did not finish. Any vehicle with a time greater than the DNF time will instead get this time. Please note, this setting has no effect on the timer. There is also the Warn If Below setting. If the timer sends any time below this time, the software will provide you a warning so you can investigate. The warning time should be set reasonably below the time that your fastest ever vehicle can achieve. Depending on which timer you select and even what scoring method you are using, there may be other timer options that will show up over on the left-hand side. You can find a description of these in the software's help file. Let's go ahead and do a timer test. For this demonstration, I will use the Fast Track timer. Make sure that your timer is connected to the computer and is powered up. Note, you do not need your entire track setup in order to test the communications. You just need the timing system, its start switch, and the cabling to connect to the computer. I have my timing system sitting right here next to my desk. To start the test, click on the Start Testing button. You will then see an info screen. It is a reminder to make sure that you are not currently running any other type of serial port software. It also points out that if you run into communications problems, click on the Troubleshoot button. This will take you to the troubleshooting section of the software's help file. The information in that section can help you resolve the majority of communications issues. I'll close that info message, and now the software indicates that it is now listening to the serial port. That does not necessarily mean that the software is able to communicate with the timer. However, with some timers, the software can warn you right away if there are no communications. With those timers, you may see some information show up in the Timer Data section. Anything showing up in the Timer Data section is an indication that the software has successfully communicated with the timer. If you get that, that's great. No matter if you see any data in the Timer Data box or not, there's a couple of tests that you should do. We will first do a test where all lanes finish. If your timer is not connected to the track, you should go ahead and hold down the start switch with your fingers. Now, click on the Test Heat button. A nag screen will let you know to make sure that you review the owner's manual for the timer to make sure that you are operating it correctly. Check on the box in the lower left if you do not want to be pestered with this message again. Now, wait until the indicator turns yellow and the button indicates ready. That is when it is okay to release the start switch to start the heat. Then make sure that all lanes finish. I'm going to wave my hands over each of the lane sensors to do that. Note, some timers will not send any results data to the computer until all lanes have finished. My timer's display is showing results for each lane. If communications are working, the results from the timer will show up in the timer data box. You will also see the results listed for each lane in the times section. If these are opposite of what you want, you can either turn the timer around 180 degrees on your track or click on the reverse times order box. This setting has no effect on the timer, it will just flip the times around in the software once they are received. One thing to note, with some timers, you may see the indicator go from yellow to green. That is the timer telling the software that the heat is started. However, not all timers will tell the software when the heat is started. With those timers, the indicator will remain yellow until the results are received. If you didn't receive any results, you can press the escape key on the keyboard to abort the test. We are going to do one more test. For this one we are going to do a heat where not all lanes finish. Hold down the timer's start switch. Now, click on the test heat button. Wait until the indicator turns yellow and the button indicates ready. Release the start switch to start the heat. Now, have all lanes finish except one. Many timers will just wait for all lanes to finish before they will send the results to the computer. Go ahead and press the escape key to stop the heat. If supported by the timer will then send the heat results that it has. Any lane that did not finish will get assigned the DNF time. So, with these two basic tests, I've successfully tested my timer with the software. I can quit testing at this point, but there are a couple of other timer features on this tab that I wanted to go over. The reset timer button will send the reset command to the timer, which should cause the timer's display to reset and get it ready for the next heat. You do not need to use that button normally. It can help you with troubleshooting to verify that the timer is receiving a command. You can also send a command to the timer. This is also something that you do not normally need to do. To send a command, enter a command supported by your timer into the box. Then click on the send button. Any response by the timer will display in the timer data section. When you are done testing your timer, click on the End Testing button. Note, if you are unable to get timer communications, click on the Troubleshoot button to review the troubleshooting information in the software's help file. The software can interface with two other electronic devices, a solenoid start gate or a drag racing style Christmas light tree. The software can interface with one or the other of these, but not both. If you are using a solenoid start gate that is tripped by a light tree, we will cover that in the light tree tab. On the Solenoid Start Gate tab, we are going to go over using a solenoid start gate. First of all, what is a solenoid? A solenoid is an electronic device that pulls a lever when it is electronically activated. That activation can be by manually pushing a button on the solenoid gate's controller box or via the computer. When activated, the solenoid will pull the start gate's release lever, causing the vehicles to be released. This photo shows two types of solenoid start gate. Note, there are other types of solenoids that can be used and different ways to mount them to the track. Also, some solenoid start gates do not come with a computer interface. So, why use a solenoid start gate? If a person is manually pulling the start gate's release lever, there can be some inconsistency in how they do so, from heat to heat. This inconsistency can actually cause some variation in vehicle run times. Using a solenoid start gate can give a much more consistent start to each heat, greatly reducing the chance that start gate operation will affect the vehicle run times. If the solenoid gate is compatible with triggering via a computer over a serial port, you can use GrandPrix Race Manager to trigger it. Personally, we don't like using the software to trigger a solenoid gate. Instead, we run the software in hands-free mode during the race. In hands-free mode, you do not need to have anyone operating the computer. The computer runs itself and the action is controlled right from the track's start gate. This gives added flexibility to get the racers more involved in the race, if you can. For each heat, we like to have the racer from lane 1 come up to the track's start gate. We do a 3, 2, 1, go countdown, and that racer pushes the solenoid gate's trigger button to start the heat. Racers very much enjoy being able to do that. Note, we will cover running the software in hands-free mode in the video for step 9, run the race. If you do want to use the software to directly trigger a solenoid start gate, click on the Enable a Solenoid Start Gate box. Select the output pin that the solenoid gate circuit is connected to. For a serial port, that will either be pin 4 or 7. The time on is the amount of time that the solenoid is to remain energized before it is turned off. This should be set long enough for the gate to swing out of the way of the cars. Then make sure to select the serial port that the solenoid gate is connected to. This can be different from the serial port your timing system is using. To test the solenoid triggering, click on the Start Testing button. Then click on the Test button. The software will turn on the specified output pin for the amount of time specified and then turn it off. The indicator will turn green when the pin is on. To complete your solenoid testing, click on the End Testing button. If you are unable to get the solenoid triggering to work, click on the Troubleshoot button to review the troubleshooting information in the software's help file. Before I show you the light tree functionality, I will disable the solenoid start gate. As I mentioned earlier, the software can trigger either a solenoid or a light tree but not both. The other device that the software can control is a drag racing style Christmas light tree. To interface to a compatible light tree, go to the Light Tree tab. Some light trees will trigger a solenoid start gate when the green lights come on. If you have one of those, you will not enable the solenoid start gate in the Solenoid Start Gate tab of this screen. The tree will trigger the solenoid, not GrandPrix Race Manager. To use a light tree with the software, check the Enable a Start Light Tree box. Select the trigger pin. For the serial port, this will be either pin 4 or 7. Some light trees will accept a signal once all the cars in the heat finish. If yours does, select the appropriate end of heat pin. This cannot be the same as the trigger pin. If your light tree does not support an end of heat signal, you can set that to not used. Set the time on signal to the appropriate amount of time. If you are not sure what that should be, select at least half a second. This is how long the applicable serial port pin will be kept turned on when triggered. Then make sure to select the serial port that the light tree is connected to. This can be different from the serial port that your timing system is using. To test the light tree, click on the Start Testing button. Click on the Trigger button to start the light countdown on the tree. The software will turn on the output pin for the amount of time specified and then turn it off. The indicator will turn green when the pin is on. If your light tree supports the end of heat feature, click on the End of Heat button to test that functionality. To complete your light tree testing, click on the End Testing button. If you are unable to get the light tree triggering to work, click on the Troubleshoot button to review the troubleshooting information in the software's help file. For more information on hardware settings, you can click on the Help button. When you are done making changes to all your settings, make sure to click on the Save button. Now that we are back to the main screen, you can see that the completed box for step 4 has been automatically checked for you. This completes our video for step 4, hardware settings. Stay tuned for our video for step 5, where we will cover defining competition groups.